Okay. So, like I was saying, you want to. So if you want to create a database, you just come to your local server, you right click like this, and then you see create server again here. You can create a server inside the server, but that's not what we want. We want to create a database where we can store information. So you click here, and then it will require that you enter the database information. So we are creating a church management system. So you just do church DB. You can leave the rest to default for now. And behind the scene, this is the query is right. It's right. Create database with the owner as the Postgres, and these things are unicoding and connection limits. As default, you can add your comments here, but leave everything as default. And then it creates. So the moment it creates, you come to your ignore the databases here. Let's come here. And sometimes when you create your database, you might not see it here. So you just right click and refresh. And let's go back again. And that is our database here. So I'm using a snake case way. There are so many ways you can use, like using creating a database. Someone can use a camel case to create, but this is my style of creating my database. So all of my databases are snake case names. So this is it. So inside the database, I can just write a query. So anything I do here will write a query into that database because it has selected it. If you write any query, it will pick the database. There are a lot of databases here, but this particular query will do justice to that. So the first question was create a data. Okay, so let me just write it quickly. Yeah, it said create a table that will collect information of a church members of church members. There's no F. And so what's taking the following information, and that is one. We have the ID as integer. We have the first name as varchar. We have the last name as also varchar. And we also have for the location also varchar. And we have lastly the gender also as car. Okay, so let's solve this question. I've commented it so it won't create any issue. So in our assignment, I gave a hint, which is number 3, the create table. So the creates, this is a keyword table, then you write your name. So the table name should be called members. And it's going to take the following data: ID, which is int, first name, which is varchar. So let me just give it 20 The 20 indicates the number of characters in the name. So there's no one whose first name will be more than 20 characters. So that is it. And what again? Last name. Also Vaka. There are a lot of validations you can add. There are some fields you can force it to be not now. Not now. I think it's no now. No. Then you set it to false and all that. But right now we are just doing the basics. The basics. Location. Vaka. Location can be more length, so let's give it a length of 100. And gender, which is a character. So basically this is what the assignment was telling us to do. Now let's try and run it and see. Let's hope it runs. So our query is done. So when I refresh this page, what I did, you can manually do it, but I just wanted us to get used to the SQL queries. I hope you get it. You can do it on the UI level. Yeah. So when you come here and you go to tables, you see members and you see the following columns I created, which is the ID, the first name, the last name, and the location over here. So now the second question was, now we are done with the first question, number 1. I hope if anyone has a question here, you can quickly ask and I'll sort you out. Does anyone have any question? I hope you all did it this way. So this is question 1.
Hello?
Yeah.
Yes. So actually my table, it seems I didn't create it this way. So I'm sure what I did wasn't a database.
Okay.
Because yes, I'm sure because I didn't create the table this way.
Okay.
And
it didn't appear here as a table.
Yes, it appeared as a table, but I think it came into when I created a server. There's something called schema. There is a schema. So within the schema that I created the table. Okay. So
Okay, I get it. I get what you did.
Yeah.
It's also another way of creating tables. If you are working with like a huge set of database, like some people try to use schemas to, segregate the tables and all that. Yeah, that's complex.
Okay.
That's a bit complex, but it's also, I think it's one of the allowed things you can do. We can dive into that.
Okay.
Yeah. In fact, where I work, that's what we use schemas a lot. Yeah. So you are not far from wrong.
Okay.
It's not within the domain
the
of
context of what you are doing.
Of these questions. Okay, so you are right. Your listener is right. So we'll go with that. Right. So if I'm supposed to mark you, you are correct there. So don't worry. So the second question was insert into the database 10 members. So we are going to do that quickly. Insert into the table at least 10 members. Okay, so at least 10 members. This is the question 2. So
agenda.
We are going to insert. I always miss the spelling of insert. I don't know why. Then you call the table name members. So over here, this the insertion query is also a hint I gave in number 4. So insert into this thing that you call the various fields. It can be a mixture, but you should know that how you call it here is how you insert into it. So if you can start with location here, ID here, you get what I'm saying. But
Yeah.
the moment you are trying to add the values, it has to conform. Last name and gender. But I want to just go according to here. So let me just come to here and this way ID. And then here values. So the first one is ID. I'll just give you 1. Location, I'll just say when we get there, we cross the river. So Tang. First name, yeah. Last name, okay. Yeah. Last name, Ofo, Wa, and the gender, I will say F. Now let's just try this one. If we don't get any error, we just duplicate, and yeah, so we have one member inside the table now. So if I come here and do selector, we are going to get Yakoriwa, who lives at Pantine, and it's a female over here. So we are going to do the same for the others. Where's my query? Okay, so I'm just going to copy this n times and just share the name. Well, there's another in the programming. What I did, there could be a better way of doing it. Someone can just use one line and then write queries. So you can just write one line, set a variable to maybe 1 and do an if condition to just run this. No, let me not just confuse you guys. Let's go to the basics. So this is just basic. When you start doing store procedures and all, you have so to Nima, Mariama, Hussein, 3. Let's call this guy Madina, Kofi, Buedi, Semil. So I'm just giving them unique IDs. So that's La Paz, Amena, female. Let's go here, 5. Here again, La Paz again. Step in. Amua, new. 6. Here again, Alpha, Wow. Name 7. Action mortar. Christina. Sorry. F. Wow, I'm good at names. Ablekuma. Blessing. Ade. Yeah. I'm tired. If I was writing an if query by now, I would have been done. No worry. Adenta. Malis, it's making you guys. So this one I'm going to spice it a little. I just want you guys to know that I can just do it anyhow and it will still work. So I'm starting with the Adenta here because I've started with my location here. And first name is T Gray. So let's take note of T Gray. And I'm bringing the ID here. So the ID is 9. I intentionally did that so that you guys will get to know. Let me name again. Airports. Junction. Erica. 10. Yes. Okay. So because we've already run this, let me make this person 11. And probably see. Okay, let me comment you out. Okay, so if I run this right now, okay, so all these rows are now inserted just like that. So to confirm, I will do a select all query. Okay, so the next, I think the next question says select all members that are females. I hope you guys can see my screen. It looks like I'm going down. So the next one is C. Question 3. Select all members that are female. So who can give me the query? Who can give me the query? Since you guys did the anyone?
Okay, so select
Okay.
all from members.
Which all? Is it this all? Or
No, don't. Yeah. Select all
okay.
from members.
Okay.
Where
And
gender where gender equals male.
equals
female,
male.
yeah. Which one are we doing? Is it female or male?
Female.
Yeah, so
Female.
it's well, yeah, so female.
Okay. And this is the result that we had. So I picked Ya, Mariama, Amina, Erica, Faustina, and another Ya again. Ya Mansa. So if you go here, you see that everyone here is F. Female. Okay. So anyone has idea for the next one? The next one is select all members that are male. Or that are male. So select. Someone should help me.
So select all from members where gender equals M.
Okay. Okay, good. So we have Kofi, Steven, Yao, and Blessing Avevo. All male. So that is it. Now, all this you guys are doing, imagine you have a code sitting there running all these things for you. Then you give it to the mobile or the web application to just display the people's information on the table or something for display. So basically, this is the basics of everything we are doing. If you don't understand this concept, we can't build on top of it. So this is the asienokra, the source of backend. You understand? So the other tricky one that I gave you guys, I wanted you guys to actually visit one site and learn from there. So we are going to visit it from here together, and I'll show you how we can learn from that side, because that's going to be our main. And so so when you go there, you see a lot of programming languages over there. Any of the stacks that you go, you see introduction way to the end. Now, I since we are learning SQL, you just have to click on this one, this link. It opens. It tells you what to do. SQL is a standard language for storing, manipulating, and retrieving data in a database, and that's what we just did. Our SQL tutorial will teach you. So even here, if you don't have a PC and you're doing it on your phone, you can quickly try your hands on certain things, and you're already familiar with select all from this. And they sometimes give you quiz. So what we started was to create a DB, drop a DB. That one we've done it. Backup a DB. We'll do it later. Create a table, drop a table, alter. So there are a lot of things I might not teach you, but I'll reference you here to come and have a look. So there's this one thing I wanted you to come and look from here, and that is select counts, and that is it here. Now this one allows you to manipulate the data, get to know the number of people who are female, number of people who are living in La Paz, the number of people who live in Medina, all those things. So here is it, and it's simple. It tells you, I want to show you how you can quickly use the queries for your own assignments. I can give you an assignment and you just come here and you just come and copy, manipulate it to do whatever you want. I need you to understand how the site works. So this one says SQL counts, SQL average, SQL sum. The SQL counts, average or the AVG, and the sum functions. The count function returns the number of rows that matches the specific criterion. So the criterion we are going to put here in our column is the gender, and we want to know the count. And the condition is where we place that the people are female, the people are male, and all that. So let's go there. Let's go to our query, and that's our question 5. Select all counts. At this point, if you have any question, I'm giving you the chance to ask, else remain silent whilst we continue. Any question? Select counts all members. So all members. So we want to know the number of members that we accumulated their information. So as a lazy man as I am, I just take this and take the ID because I just want to know the number of people. So this one will take the number of unique IDs on the platform and then count them. So it will take ID 1, ID 2, ID 3, ID 4, add them. It's not like the ID as in adding as a sum, but adding each row together. Then I change the name here to members. Then I put in the condition. Right now, there's no condition. I just said select all count members. So this is all I need. I don't even need this. If there's a condition like select all count members who are so and so or who live in so and so, then I'll add a lot of conditions. So for now, if I do this, it's going to just return me a count of 11 members. So we have 11 members in the table. Now I can just say as number of members. That will just change the title here, but by default it just picks the count just like that. So that's it. Now the next question was select all counts who are females. So we do same who are female. Can anyone give me an idea what it will look like? So still we go here.
Okay.
I'm listening. Yes, stop.
Okay, so select. Hello?
Yeah, I'm listening.
Select count ID.
ID.
Yeah, from members. Okay, select count. Hello?
Yeah, I'm listening.
Yeah, select count. Select count. Let's say, okay, let's use ID from table from members.
I think
Okay.
gender, because it's the gender we are focusing on.
But the where condition, I was looking at using the gender at the where condition.
Okay, you continue. I'm just correcting you here. Where from members, where
So where gender, okay. Okay,
so let's try this and see.
Yeah.
So now it has returned that we have 6. So in total we have 11. So by default, if they are telling us that we have 6 females, how many males are we going to have?
5.
Okay,
5.
so if our query is wrong, we'll get to know it here. So we have 5. So
Okay.
are we good? So this one is for female. We can just say as female. And we run this and it just turns this. So any question from here? If no question, hold your. I will share this with you this time around, not a screenshot. I intentionally shared the other assignment as screenshot so that no one copies. I just want you to be typing. That's why I intentionally didn't. So this is the answer to our assignment that I gave. So I'm going to share this right now before I forget. So let me just go to our group page and just paste it here. If you copy it, you put it in a postman or something, and you share. So that's the assignment and then the answers for you. Okay, so today's topic, I chose very simple. It says primary key, foreign keys, indexing, and auto increments. So, like I said, we are all our whole thing learning. We are going to just do it here. So let's just look for primary key, foreign key, and then indexing, auto increments. So let's come here and know what primary keys are. So SQL primary key constraints. SQL primary key constraints are unique identifiers which records in the table. The primary key must contain unique values. And unique, note, unique in capital. That's a primary key. And cannot contain null value. A table can have only one primary key, only one. And in a table, this primary key can consist of single and multiple columns. Okay, so let's go back to our assignments, our file, before we even continue the tutorial on that page. I just want us to look at what we read. And so now let me open this. Who can guess what the primary key is? The primary key must be unique to each row and it must not be null. So from this table, who can guess what the primary key will be? You can just, yes, the ID. Why?
Okay,
Because
so the primary key
should not repeat. So if you look at the gender, you can see that F, F, M, F, F. So this is definitely not the primary key because each column must be unique. A value should not repeat again inside the column. When you come to this side, you can see that La Paz has repeated twice. So this is definitely not a primary key. It's not a unique identifier. A unique identifier helps you to just pick a single row from a table. And when I say select all, where location is equal to La Paz, I will get Amina and Steven pop up, and I won't get a unique value. And that's not what I want. The same thing if I say select all where gender is F, I won't get one person. A lot of people have one gender. When I come to this side too, this side is a bit tricky. Might look as if it's a primary key because everyone has a unique surname. There's almost no one with the same surname. But you know Ghana here, there are a lot of Bwedi in the system. There are a lot of Foriwa in the system. There are lots of Asari. There's a lot of, even look at Ofori and Oforiwa, they are even close. So this is definitely not a goal for a primary key. The same way comes to the first name. there are a lot of Kofis in the system, and there's a lot of Ya, Erica. All these names are common, and this place can be considered as a primary key. But here, the ID, you can see that it's an incremental field, and everyone is unique. Nothing is repeating. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, we can consider this column as a primary key. Hence, when we want to just fetch a row that points to an ID of 3, we can easily fetch this and we will get the details there of that person. At this point, any question? Any question? So I'm going back to the website. This is where we are using to play. So it says create table, as we've done, indicates this. Now, the moment you bring the not now, it's trying to tell you that anytime you are inserting, you should make sure that you place some value there, else the table will never save. It will tell you that, hey, you haven't given me any information. That's why it's now, not now. And the last name, the same thing. There's no one with without a last name, so not now. These are some validations you put on your table to avoid wrong data entry, and also it's a kind of security you put on your this thing. Even data type specification is also another form of data type validation, or data filtering or validation, so that you avoid people from entering wrong information. So for instance, someone can omit and forget that, oh, I have to add my last name. So the system, when you set a table and you put this not now there, it will avoid that. And you create a table to do that. So don't worry. We also have first name. This one, you can see that there's no now there. So that means you can enter the table without adding a value here. And this makes it not qualify for a primary key. The same indicates age. So there could be a lot of people with the same age, 15 years, 15 years, 15 years. So this place can be. So now, this is where we specify that after creating everything, set the ID to be a primary key. There are so many ways in doing it. You can just copy this and write it right after the not now. And this is done in my, this is what makes the difference between my SQL, Postgres, and the rest different. So this can be only done in MySQL. Although the query looks similar, this can be only done in MySQL. This is how it's done. And this one can be done in SQL Server, Oracle, MS Access. You can just write it continuously here and it will work. And this one can be done in both MySQL, SQL Server, Oracle, and Access. As you can see, it's almost the same. It's almost the same, but no one will go for this. Like writing it manually, no one will go for this because it's a bit. You're now coming to write constraints, and you write PK representing foreign key on this table, and then you pass this, blah blah blah. Like it's a whole lot. So the easiest way to go is with this one. So I'm going to copy this. We try it ourselves. If it doesn't work, we fix it together. Go to queries. Query history. I want a new query. Query 2. Okay, so I'm going to create a table called departments. This is how we create applications. So right now I've created church members, and each church member can be in a department. So I'm creating departments and I'll insert the table. So departments. And I want to set a unique identifier for each department. Then I'll just give department name. So I can just say name, DPT or yeah, I can say full name. Let me give it a DPT name here. So this can be taken out and this can be taken out. I'm just taking the department name and the yeah. So this only thing I want to create inside that data the church. So each department has a name. That's all. I can just add description. What the department do. So description. Bar. I don't know if text work here. Text. Yes. Text. Text means that I'm going to write a whole lot of information. And Baka can't take that. So yeah. So now let me run it. Fingers crossed. What's he saying? Okay, I didn't bring a comma here. Sometimes. Okay. So it has created it. Now what happens if I want to create again in that same table? I've not tried. So I've done it several times. Let me go and see. So it was telling me relation data department already exists. So it's not allowing me to create multiple tables at the same time. Let me be quick. It seems we are getting tired. Some of us. Are you tired already, or you are not? Yes. So departments. So now we have our department. This is our column. Now let me try doing one insertion, and then let me use the UI to do it. Where is it? Where is it? Where is it? Insert. Well, insert scripts. You know what we are doing, or we can do it on the UI, but just that I was trying to just let you know, guys know. So you see, it has generated everything for me. Insert into the department, this, that. I will try and avoid this one and see the error you guys will see because of the not now I brought. The department name, pastoral board, and description. I'll say these are the pastors of the church. Now I didn't add an ID to it, so let's see. Aha! So it says what? Now value column on ID violation, not now. Sometimes the error will show you, will try and talk too much. You might not understand, but then it's trying to tell you that you have to add an ID. That's all it's trying to tell you. So like I said, you can put the ID anywhere, but make sure you add it. So instead of ID, I just put 1. Now if I do this, voila. So if I do select all from departments, I'm supposed to now if I highlight like this, it will skip this and come around this. So the moment you highlight a field, a query, it gets to know that okay, it's saying you shouldn't run this, come around this. So we have the pastoral board, and these are the pastors of the church. So that is it here. Now you understand. So this is a primary key, and it always shouldn't be now, and it should be unique. Back to the sites. Now let's go to a foreign key. So you can sometimes create a table and later you realize, oh, I didn't add the primary key like we just did for what is it called, the members. So you can just do alter table. So if you don't understand how tables are altered, there's a field, there's an author table full tutorial somewhere here. Just look for it and play with it. Like I said, I want you guys to be familiar with this site and learn a lot. It's not everything I can teach you, but then sometimes if I give you an assignment and it's challenging, you can go there. And so if I do alter table and I change members and I convert this and I select this, it's gonna run. Now it will only run if one it identifies that the row is not now. Like there are members in it, but the row is not now. And also the data in there is unique. That's when your query will run safely. Now, if you now try and insert like we just did and then you omit the ID, you get an error. You can do that, but because of time, you can just go and try it yourself and come and give me a feedback. Or if you still doubt if it will work or not, I can just quickly copy this. And I like copy and paste a lot. So sometimes the code, you might think I know, I don't know. I like copying and paste. And maybe you shouldn't pick my habits, but then that's me sometimes. But as a newbie, I would advise you, even if you know, type it. Type it because it will help you. So as I'm copying and pasting, don't do that. So if I do this without the ID, I'll get an error, the same error here. But before then, if I had done it without the ID, it would have worked. So now quickly, let's go to the foreign key and just do that. You see, the assignments, the tutorials are very short and easy to practice. I hope the site is useful. So foreign key
Yeah,
constraints. Yeah, foreign key constraints.
very,
Um,
very useful.
yeah, so a foreign key constraint is used to prevent actions that would destroy link between tables. Now we can create link between tables, and I'll show you a typical one right now. What's the name? A foreign key is a field or a collection of fields on a table that references a primary key of another table. The table with the foreign key is called the child table, and the table with the primary key is called the parent table. Now, take note here. I said the table with the foreign key is called the child, and the table with the primary key is called the parent. Now, they've spoken a lot here. Now, let's go to the practicals. You understand what I'm saying? Now, we have a table that contains departments, list of departments. So we have choristers, we have ushers, we have deacon and deaconesses, we have children's ministry, we have. I'm trying to bring like the real world. This I'm not now going to bring Kaka. We are building maybe a church management system. So you have a table that just stores the church's department. So anytime a new department comes up, you store it. For instance, there's a hymnal choir group now popping up, or there's a bass men's something. You just come here, you create it. Now, the moment you create it, now when you're creating, maybe there are some members here, you need to link the departments to them. Now you don't have to come and rewrite the department name and their description to each of the members here. Let me select all again so I can see this table. So assuming you are supposed to link each department to these people, it's not now they're coming to create another department ID, department, and all that, and then write each of them men's fellowship, whatever, like it's redundancy. And we call something called normalization. Everyone write it down. Normalization. Go and read on it. I won't teach you about next week if I come. It's one of your assignments. If I come, at least I need you to share your idea on it. So please write normalization. Can someone write it on the group page for me on Skype? Normalization. Database normalization. Mr. Dazi or Kofi. My active students, please, someone should write it down for me. It's called
Okay.
normalization. Yes. So next week I will ask about it. It's one of your assignments. So to not make our table so redundant and all that, we just have to create a foreign key that will reference each table in the department. And the foreign key here will just take the IDs of the departments here. So I'll create more departments. You guys will give me ideas. I'll create maybe something, then I'll just, so this, if I just create a column, so a column on the members table, you understand? And it references this. Now this is the parents table now, and this is a child table. It's a child table because it's picking or inheriting data from this table. It's not bringing all this table to attach to this, but because of the foreign key mapping to this, it will, anytime you call it, you can easily add, get to fetch the name and description of that member's department. This is a bit dicey, but I hope you understand. This is a layman's description. This is the point where you say or you ask a question. So is it or there's a question?
Please explain again.
Thank you. So right now we've created a table that stores members' information, their basic information. That's their name, their last name, their location, and gender. We also have a table that stores the church's departments. The church's departments, as in we have the pastoral board, we will definitely have choristers. Let me add more so that maybe you can understand better. So where was the insets? I don't like typing, no. So please forgive me. Let me close this table, this one. Let me close some of them. Remove some panel. Insets. Okay, so this one, right? So let me just add. Please give me names of departments,
The drums department, instrumentals.
Okay.
Instrumentals. The ushers.
Okay. They play instruments. So when we do this and run, and then we have ushers. Oh, I think let me call them protocol. Or
Okay, yeah, go ahead.
Manage church activities. I give them an ID of 3. And we have the choir. They sing. And I'll give them 4. I think for now, these are the basic. We have the what's there. Finance. Finance. Okay. Manage offering, something like that. 5. Okay. Now, right now, when we go to departments, so we have these departments. Wow, we have all these people. So we have, you can just picture the number of people that can be in choir. We can have about 70 people here. We can have about 5 or 6 people here. We can have about 10 people here. We can't be writing pastoral board. They do this on each of this table. Like, let me select again. Now I want to add each member's department against his name. So maybe Ya is in the choir. I can't write Ya, then I write qua, and I'll explain what he or she does to each of them again. So the only solution is just put an ID there that will reference this table for me. On this point, I'm pausing. Do you still not get it? So I'll add an extra like column here, which is also a form of ID, but now it is not a primary key here, but it's referencing to the primary key of the departments. So here it's a foreign key on this table, but then it's a primary key on this table. You still don't get me. So over here, the let me close some of this one. We are done with it. So remove. Don't save. I don't have it again. This one. Remove. Remove. Then keep this guy. Select all from departments. Let me do this guy. So you get it. I don't want to keep repeating pastoral board, these people like against the column. So I just have to have a column, cut this side, and map it to these people. So you understand later. Let's go back to the website. So over here, this is a typical example. So we have a person and we have the orders that the person has made. For each order, so this is the person's ID. And for each order, we have one person can have about 3 orders. Order means the person's order some food or something. So in a day, each of the orders that you order has a coupon number. So instead of writing the person's name, first name, age against each of the order, which will be too long and waste of space, you just pick the person's ID and put it here. So now, if we pick this order and we say who is it for, we reference this ID, will reference this table. And when we come here, we'll see 3, and we know that, okay, it is for Patterson Carey, who is a 20. And we come again, we look at this order. This is order number 44678, and it belongs to number 3. So number 3 is a foreign key. So we will go back and reference this table, and we can see that number 3 is the same Patterson Carey, 20 years old. And we come here. Okay, so we have another order 22457. Who do you think it belongs to? We come here and we know that, oh, it belongs to Tovos something, who is 23 years old. And we have another one. So this one is avoiding the way that we always rewrite this whole information here. You get it?
Yeah, I understand.
Yes. So now this is the parent table, and this is a child table. It's a child table because it is referencing the mother. So it's like
you I want to say something now. So per my understanding, if you want further or extra information about details of members on the parent table now, that becomes the child table now.
Yes.
If that makes sense. Like,
yes. So from the parent table, you can reference how many children the parent member has in the child table. So Patterson has 3 orders. So Patterson, in other words, Patterson has given birth to 3 people here in this table. And you can also say for each of the rows here, who does he or she belongs to in the parent table, or whose parents does the person belong to. So if you can see that these 2 rows are children of number 3. And when you come to this one too is a child of number 2 here. And this one is also a child of number 1. Now, if you notice something, these rows are repeating, and it's okay. Foreign keys can repeat. But the only thing that we can't allow it to repeat on the table is a primary key. A primary key in any table must be unique because it is for that table only. So when you come to this parent table, the IDs here is unique. It is never repeating. The same here, it is never repeating. But this is a foreign key. It is referencing another primary key, so it is allowed for it to repeat. So you see there's 3 here, there's 3 here. There can be a lot of 3s. The same thing, there can be a lot of 2s and 1s. It's allowed. But then we should just bear in mind that it is referencing a different table and avoiding the abuse of over populating or repeating too much data, which is not necessary. So this would have, if not for this foreign key, we would have created this whole table against this table again. Meanwhile, we have this table. You get it? Hello? Yes. So I don't know if I should give it to you as an assignment or I should do it for you guys. I think I have to give it to you as an assignment.
No, do it for us.
Okay, so let me do it for you guys. So first of all, in order for us to map our members to our departments, we have to alter the table called members to have a foreign key. You understand? So let's go down, 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 and now you can see that we have this is the same thing. Now this one is already creating table. It's like it's creating the new table fresh, and then adding it. We don't want such queries. We want a table. We've already created our table. So now we want to just alter. Assuming you are creating the members table fresh, then you use this one. I hope you understand. But we've already created our members. We've already created our members table. So we just need to alter our table to have that how do you call it? That's foreign key. So let's copy this. Usually I copy the one that has SQL Server, Oracle, and all that. I think this and this are the same. I don't even see the difference. What's the difference? Okay, I like the simplicity of this. I just don't like the FK whatever here, but it's almost the same thing. Now you can. Now let's go here. I don't like typing, like I said, so I just go here. All we are doing you can actually do it with the UI. So I just paste it here. So alter. Now you know we don't have any others table. So what we have to put here is what? Members. Members table. And we add a foreign key, a meaningful foreign key that anytime you come, you understand. So I'll call it department ID. Now, I was trying to use underscore. So this is also a good way of naming a column, but I prefer using this. Now, where is it referencing to? It references the table called what? Help me here.
Department.
Thank you. And what do you think it is referencing it from on the departments? For the columns
department, here. Department ID.
Thank you. So it's just ID. The column name is ID.
Okay.
So it's just, so if I run this, did it run? Is that what?
Error.
Okay.
The department ID.
Okay. Foreign key alter, foreign key, add foreign key. What? Okay, okay. So this one is telling me that there's no column name called department underscore ID. So why are you even at the first place altering that column? Yes. So what we have to do is go back to the site and see how to alter a table. You get it? So we are altering a table to have that column first. And that one, I think it's somewhere, order table, create table, order table. It's here. So sometimes when you're looking for something and you can't find, just do Control F, alter table. So just come to highlight where you want to go. So for us not to lose focus, I'm just opening it in a new tab. So to alter a table, this is what you just do. Copy this. Like I said, I just don't like typing, so and alter table, members, add column, I'll call it departments underscore ID. And then the data type, I'll just put int. So now I can just do this and it has created it. So now when I refresh this, I should be able to see department ID added. Now, I'm now going to reference that ID to the other table. So now when you run this, you will not see any magic, but behind the scene, it is referencing that table. Now, the reason why you need to write this is that assuming I am trying to enter any ID that has not been created here, to tell me, please, who are you referencing on this table? So let me go back and explain that one. The reason why you need to reference. Assuming I come here and create an order maybe 011, and then let's write 4 here. What do you think will happen? 4 or 5 or 10 at the person ID column.
Because 4 is not in the parent or the parent table, it will tell you that it doesn't exist.
Thank you very much.
Because it's not part of the parent table.
Perfecto. Yes. So that's the reason why we write that script. Although you don't see any magic happening behind the scene, before you insert, the program goes to check, hey, if that is that person in the parent table. If that doesn't exist, please, we are sorry, we don't even know anyone with an ID in that table, so you can't create the table here, or you can't reference anything here. So you will try and play around and see.
Okay, so I have a question.
Yes.
Okay, so assuming that you have created your table, your parent table, and now you have created a child table, and you have to, like how we are doing, can't you just go to the parent table and create a column, and then use it to reference the child table instead of writing codes for it rather?
So you don't write the code. You see, they've done it easily for you. That you just have to just be inserting, and it will go and do the referencing for you. So you just try it. If I'm answering your question well. Now, there are some information that you just write once and you don't need to repeat again. Like it's just there in your reference, like the department information. You don't need to be always writing department information. You just write the department information once on a particular table. You reference it anytime there's new. And in fact, assuming now the qua is now called the Glorious Temple qua, and the qua information is displaying on the app that the person belongs to the qua. And there are about over 100 people you've not referenced, but you manually wrote everything on the column. Like qua. That means you have to write a script that will iterate through the 100 people in the table and change their department name. Meanwhile, if you just come here and just say all glorious temple qua, just here, it affects all the people, and you don't need to do like that huge query to reference. To iterate through. You understand? because the ID doesn't change. It's just the name you've come to change. So if you just come here and write Glorious Temple Choir, everyone has the name tagged as Glorious Temple Choir. So we'll do some like the pastoral board I've written. It can be today not a department. It can be something else, and they want us to change the name. You understand? Yes. So now it's up to us to now map. Right now, if you do a query, select all. Select all from, sorry. You can see that we have an extra column which is now, and it's acceptable. A foreign key column can be now. That means that they've not been mapped to a department yet. But then right now they have the opportunity to be mapped to a department, which is this table. So now Ya or Foriwa can be in the choir, and we just map it. We just write a value here, and then we will know that it's referencing. So all we have to do is what? Update the table here for Ya Foriwa to have a department. And to update a table, we go back here again, look for updates. So this is an update query. Let's go and see how it's done. So update this, set the value to this, set where. The where condition is very important. So this is where the primary key plays role, key role. You see, let me copy, because we have about whose name is repeating here? No one. Okay, we have two people in La Paz, and we want to just, they are saying, oh, there are some two people being in La Paz, but that person's name is Amina, and I think the person's ID is 4. So go and update that person's ID and link that person to the path or the protocol. So we just have to come here again, get to know the ID of, so the ID of PA is 4. So all we have to do is insert. So insert into what? Members. Set the department. That's where we are focused on. To 4. Now the other ones, we don't need to update them unless we want to update the person's name or something. But for now, let's keep it simple. And this is where it's dicey. Now, where the ID of the person is not now 4. Okay, now I think I'll confuse you. So let me just set this one to 5. Set the department ID. Sorry, department ID. So where ID equals, now we want to update the department of who. Just give me any name and I'll update his database for you. Any name.
Yeah.
Okay, we have
Yao
Menu, who is 6.
It is 6, yeah.
Yeah, so I'll just set his ID to 6. Now when I run, and I run this again, which is select all, I should be able to see that Yao Menu, who is number 6, is now in a department, which is 5.
Department 5, yeah.
Yes. So when we want to reference what 5 is, there's a query you do and just give you an addition of where this is. And I think that's where we go to our next topic. What was our next topic? Okay, indexing, auto increment. Okay, we have 2 more before the join. Okay, so indexing and auto increment. Let's quickly go there. And indexing is simple. Indexing. So You come here, find indexing. Indexing is simply making sure so create an index statement is used to index a table. Index are used to retrieve data from a table more quickly than otherwise. The user cannot see the index. They are just used to speed up search or queries. So right now it looks faster when we did the query, but when you have about 1,000 database or 1,000 information in the table, you have to tell the computer that, okay, I'm setting index on these people, these columns, because that's where I'll always be basing most of my conditions on. Conditions is where you do where the value is equal to 3, where the value is equal to 4, where this. So it's something that when you run, you will not see, but then behind the scene, it runs faster. And if I could have gotten the time at which this query ran, I would have loved it. Then later on, I will. So this is 100 milliseconds, right? So I'll index the column. Yeah, a bit when I did it was 100 milliseconds.
Yeah.
Now it has come to
62.
62. Let me try again. Okay, at least it's around 50 thereabouts. Now, let me try indexing the field ID on this. And then let's see, maybe to reduce. Then we will probably see the use of index. So, for instance, this one, so create index, the index name on a table this, and you bring the column. To create index duplicate value or allow. Okay, so create a unique index in a table. Duplicate values are not allowed. So this is what I want. I want to create a unique field where duplicates is not allowed. So I'll pick this. I'll pick this one and come here. Oops, where am I going? I want to just, we are not yet here. Please, sorry. So the rest are quiet. I don't know. Are they still following us?
Yeah, we are here.
Mm-hmm.
Okay, thank you. So I call it ID. I take this one. I'm just indexing the ID. And I think over here I call it ID, index ID. The table, I call it members. Now this query you will not see the effect, but then it works. Member. Normally when you index a table, it has to be unique. So let me see. So you will not see it, but it's working behind the scene. So now let's see whether it will reduce. So whether even increase. You not really see like the effects, but then what I did is just to help the query run faster. That's all. That's all for indexing. And you see the importance when you are dealing with like huge queries, like huge databases over 2,000, 10,000. You realize that you realize the importance of indexing. So you can read more. I think there's more down there that you can read, and yeah, that's it. So quickly, let's go to the last one, and then maybe let me see if I can. So auto increment, yes, this is the topic I want to highlight on. You see where the IDs are, you were entering the ID manually. What if you forget? You go and come and you don't even remember, oh, okay, last time I used 10 for Ajwa. So the next table row I'm creating, I have to maybe create 11 or 12 for Akusia. So there's a way of just setting that ID row as auto increment. So you don't need to even bother to insert the ID. The table automatically create a count. So the moment you add an ID, you add a value, it will just say, okay, I'm setting the ID to the last value you set. I hope you get it. And the moment it sets it, if you delete that row, it's when it's creating another table, it will not give it that ID. Do you understand? It does that. Okay, so let me go to a typical table for you to see. So so far all the tables that we've created, when I'm inserting, I'll manually enter ID1, enter the name, Hassan, Ola, and then the age. Do the same for everyone. Now, the disadvantage is that when I delete Hassan and I'm inserting again, I'll be tempted to go and write one again. Then I'll write Kofi, Ajwa, Menu, and those things. Replacing a whole new person on that ID, assuming there was a security check, they will realize that, it is this person who did this or who has this information. Why is that the person's information has changed that time? So when you put auto increment the one, it prevents you from repeating an ID to a particular individual again or a particular data again, and also avoid you from you guessing the last ID that you created. I hope you get it. So let's just move for auto increment. That's our last lesson. Then maybe I'll just give you an assignment. Auto increments. Okay. Auto increment allows a unique number to be generated automatically on a new row when a new row is inserted into the table. After this is often this is in the primary key field, which we would like to be creating automatically every time we create new insertion. So when you do this, as you are creating the table and you do auto increments, but ideal, you don't need to insert the column again. When you are doing, just insert these columns, and auto incrementally this field will be created. I mean, the value there will be added. You get it? So we just create a table, and you understand what I'm trying to say. And that will be it for our class today. I can see you guys are tired. Look, I'm tired than you. So, but thank you for staying. Thank you for staying. It was my fault. I should have come earlier. Okay, so we are going to create a table. I want a table that is relatable in the church. So I want us to create a table that will store the churches. What again? The churches branches. The branches of the church. The church might have branches. So notice that almost all my tables, I make them plural because I consider that each row represents one person, one data. So the table takes a collection of that data. So I assume that it is a plural, and it's the best coding practice. Even in the tutorial, you can see that persons, they've added s, like you understand later why we are doing that. So you have branches, and the branch will have an ID and will have a name. I can just give it name. Then, as usual, I'll set the ID as primary key. I can even add location. Baka 100. Let me make this 25. It's even too much. There's no one. So branch name 25. 25 is okay. So if I run this, say what? Auto increment. Let me see if this one works. Okay. So let me just go back to the website. The first one didn't work. There's always a better way of writing it. Let me quickly check that. Auto increment, I think.
Yeah, Andy.
Yes.
The location you didn't bring comma, so you could try that one.
Okay.
That could be the issue.
That could be the issue. Mm, yeah, that could be the issue. CO and type. But it's highlighted. Let me check. Sometimes it gives you. Okay, so this is where you go to Google and just say auto increment for. So sometimes when you're even typing, it just pops up Postgres, and it gives you a sample. Sometimes it gives you all this wahala. Just go look for auto. Just find. I'm just showing you how we fish out the information we want. So it's saying that you create it that way. Why? So create auto increments table. Stack Overflow is one of the places that we learn auto increments. Okay. So it was even giving me the so instead of writing auto increment, you just write serial. So that's the little differences between the various SQL languages. So right now, if I do this, I'm 100% sure it will allow me. Let's see, not now. Auto increments does not need any now. So let me do this serial. Oh, there's no need to even specify the data type. It will do it for me. So you see, it's done. Let me keep this one here for you guys. So now if I try and insert into the branch, insert into branch. This is the last thing I'm doing. I'll not even worry you guys again. Name, location. Now you can see that I did not even add the ID. When I do values, when I write tema, branch, locate, maybe no, I'll call it glory temple, and it's located where at Tema, in Ghana, Tema, Ghana, because we can have some in UK. We are creating a church app now that. So that's it. So right now, if I do select all from branch, okay, branches, I do spell. You should see that automatically an ID has been created for me. We good. We good.
Yeah.
So if I do another one called Hope Temple, and I call that one what's crample? Under bridge. Yeah, I give it another name, East Legon, and I have that, and I now fetch all. I have Hope Temple this. Now this can also be a foreign key on the members table. So as we have the members, a particular member can belong to a particular branch of the church. So you see, then you are building it up. Before you realize, it becomes a whole complex, and you have it. So now you don't need to worry about this. Now, if I delete um, a particular, I don't know, there's a way you can delete. I want you to just see this, then I close. That's it for me. Refresh. Now these are branches. Let me do a query for delete. Delete scripts, delete scripts, delete scripts, delete scripts. So delete from where I'm just ID is 2. So I'm deleting the Hope Temple branch. Maybe I no the no let me do the Hope Temple. The Hope Temple branch. I want to show you something. Now I've deleted this branch. Now let's go back to now I want to create another Hope Temple again, but this time around. Okay, another so Holy Temple, but it's now that one is at East Legon again. Now what will happen is the auto increment is still increasing. It will not go and take the ID of the deleted one. This is for security purposes. Assuming we are all in the database, like the way they are taking our bio information on the system for our memory card and all that. I mean, our phone card and all that. And we are all in the system. Our phone numbers are there. And one day, maybe someone deletes an information and replaces my ID there. The person's ID, like there's a fraud something, and you come and create a new. So maybe the previous Hope Temple guy did something bad, and someone has manually gone there to delete that information, like the query I did, and we don't know. And there's still an insertion, and they insert my name as Holy Temple. Now, if they come and do investigation, they will say Holy Temple because of my ID, because it's the ID we use for referencing and all that. You understand? So the way the database is done is that for IDs, it doesn't repeat for anyone, even if the field is deleted. The ID is never repeated for anyone in the system again. So Hope Temple is gone, and that ID will not, even if Hope Temple is created again, and the same information is gone, it will never be given that same ID. We consider it as a new entity. So that's the use of the auto increments, and it's for a lot of safety reasons. Now, your assignments. I'm going to give you assignments. So, one, what is normalization in database? Just a small information will help you. It's around what I just taught you. And the second assignment is create a church database with the following table: members, two, departments. Three. Branches. 4. Four. Give me something. Activities. Church activities. So I'll do it programs. So programs in the church, we have Sunday service, we have all those services. So now you guys already know that it will have an auto increment ID. So ID. Okay, so over here it will have an ID, first name, last name, location, and gender. Going to give you location, and give me something. Okay, so departments. Okay, that will be the follow-up question. So the department will just have an ID and a name and a script. I hope I'm spelling it well. Description. I think this is description. Okay. A branch will also have an ID and a name and location. And a program will be ID, name of program, and day. Events day. Yes. So maybe example, Sunday service, Sundays, teaching service, Wednesdays, those kind of youth service. You see? So the follow-up question will be, am I giving you too much work? Or it's okay? See?
It's okay.
Okay. So your
Once
last
we are
question.
learning, we have to be ready for this.
Yeah. The last question is make references to of departments, branches, and branches. That's all. Departments and branches. Make references of departments and branches to members. And 4. That's your last question. I will not add more. Make references of branch. Now programs. Program to branches. Branches to programs. No. Branches to programs. So what I'm saying here is that we have, maybe your church has Valentine's in its presence, but this is a program in the main church, the head branch, not in all the in other branches. You understand? So maybe in creating the table of program, you can add a branch ID to it. which means that each program is peculiar to a particular branch of the church. I hope you understand. And to give you an idea of the references to, over here has to have a department underscore ID, and then what's it again? A branch underscore ID. Now, I know this is a lot of work, you might forget, so the video is there, and also I'm going to give you hints. I love giving hints, so for this one, the top one, no hints for you, but for this one, create table. Let me look for a table sample and give to you. The table should have an auto increment ID field and the rest. So I've given you a sample of how a branch to be created. And referencing, example of referencing is here. So this is example of creating table. This example of referencing. Now you guys can team up and do the assignments. I don't mind, but all I need you guys to do is do your assignments. It is through the assignment that I will know that you guys are actually understanding what you are doing. Now, I think basically this is all you need to do the referencing, and yeah, inserting into table, you already know how to insert, so but let me just give you a hint. In fact, let me cut it from there. Inserting into tables. This is dash 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 dash. Then this, and what again? Or you already know, so I'm not even bother myself. Updating a table. Maybe you forgot a particular column you want to update. Updating a table. Should I screenshot it or I should send it to you as a as a file? If God touches my heart, else I'll screenshot it for you guys. I want you guys to be typing. I think that's it. That's it. The rest you can still reference them, but basically that's it for me here. Make references. I think I'm giving all the clues. So now let me select all and comment. And you have it. Yeah. So basically that's it. That's it. That's it. So I'll save this. It's a way of saving it. Okay, so on this note, thank you for joining. It's 11, and I pray this never happens again. Thanks for joining. After this, you can still send it to me. I'm not going to sleep for a while. I'm up to a task, so I'll quickly answer you. But please try and team up, do the assignments for me. It's the assignment I need. Okay, thank you very much. Have a wonderful evening.
Thank you too, Mr. Andy.
All right, bye-bye.
God bless you for your time. Bye.
Bye.